Today we discuss about some convergent sequence problem. So we start about this XYB matrix spaces and a sequence X and yn belongs to X Cartesian product Y converges to X Cartesian product Y converges to XY belonging to this Cartesian product. How this one can happen we discuss now. Okay, then we proceed further. So how we could start this one, we know about that x in tends to x in x means xn belongs to b x epsilon for epsilon tends to 0 and yn tending to y in y means yn belongs to b y epsilon or epsilon greater than 0. Then x in y in belonging to this b epsilon Cartesian product by epsilon and subset of x Cartesian product y. So x and y in converge to x y. Okay. Now we erase this problem. Next we discuss about one important topic. Okay, which one is still a sequence if n in bx with sup norm is convergent it's convergent with the induced matrix the infinity fg equal to norm of f difference infinity. Okay, then how we proceed this one. Let fn tends to f. 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 Then in the matrix d infinity, d infinity, then this means that given epsilon greater than 0, given epsilon there exists n belongs to n such that such that for all n greater than equal to n, we have d infinity if n is less than epsilon. And expanding this, we get supremum of this if n difference if x belongs to x, okay, less than epsilon for all n greater than equal to n. Then in particular, this implies if n minus n less than epsilon. Well, that means if n x minus if x less than epsilon for all n greater than equal to n. Then we proceed if n tends to f in d infinity. Okay, this implies that this implies that if n uniformly converges to f uniformly converges to f uniformly for x. Okay, now we going to converse of this problem. Converse of this problem. Okay, converse is also true. How we handle this one? If fn belongs to if n belongs to dx and converges to f belongs to dx uniformly on x, converges uniformly on x, then fn tending to f in the matrix D. Okay, now how we write? Just definition, by definition of uniform convergence, if n x minus if x less than epsilon for all n greater than equal to n, okay, and for all x belongs to x, just uniformly, if n uniformly means this one. If n uniformly means this one, then we take supremum of both sides, supremum of this if n x minus if x, okay, such that x belongs to x, obviously less than epsilon for all n greater than equal to n and for all x belongs to x. This implies that norm of if n minus if infinity less than epsilon for all n greater than equal to n. Then this implies that if n tending to f in matrix in, okay, this subnorm is called uniform norm. This subnorm also called uniform norm. Now we erase this portion and we're going to on conclusion. We're going to on concluding point. This point is a sequence if n, a sequence f n in bx norm infinity converges to f belongs to bx if and only if n converges to if n converges to f uniformly on x. Okay, now in similar way a sequence when a sequence fn in c01, that means continuous functions from 0 1 under this subnorm which converges to f obviously belongs to this one if and only if n converges to f uniformly on x. Okay, or on 0 1 better, here's continuous functions from 0 1. Next we discuss another problem which 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 is the contradiction problem. That means not everywhere this one hold. If n if n equal to xn, if n x if n x equal to xn, if n x equal to xn for x belongs to 0 1, for x belongs to 0 1. Okay, and for n belongs to n, then the sequence if n convergent in C01 norm 1, but is not convergent in C01 norm. Now how we discuss about that? We just write it. We just write it fn tending to 0 in norm 1. Since dfn0 equal to 0 to 1 xn dx equal to 1 by n plus 1. Okay, and this one tends to 0, this one tends to 0 as n tending to infinity. So dfn0 tends to 0 as n tending to norm 1. So fn converges to 0 in norm 1. Okay, now discuss about that. Now discuss about this one. This one is not convergent in C01 and non-infinity. How this one? Because 0 less than t less than 1, 1 the 0 less than t less than 1 if n t equal to t to the power n tends to 0. Okay, and and if n 1 equal to 1, then if t equal to 0, if 0 less than t less than 1, and 1 if t equal to 1, then if n t converts to f. But if n belongs to C01 and if does not belong to C0, so 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 if n is not convergent, if n is not convergent in C01, not okay. Now we're going to another problem. Now we're going to another problem. Just we discuss x and be a sequence in a discrete matrix space. X and be a sequence in a discrete matrix space. Then when does it convergent? When does it convergent? Okay, this one be a question. So we know about that. We know about that txn x equal to x if xn not equal to x and x if xn equal to x. So if x be the point, if x be the set of collection of points, distinct points, then this one is happen. Then xn in a discrete matrix space when convergent when this one is eventually constant. That means after certain terms, that means there exists n belongs to n and x belongs to x such that such that xn equal to x for all n greater than equal to n. Then and obviously this one, then d of x in x equal to x. Then xn converts to x. Okay, xn converges to x. x xn converges to x when this one happen. This one happen if and only if x be an eventually constant. Eventually constant. Okay, or xn be eventually constant. That means after certain time, this one are same, converging to same point. Okay, now we discuss further. Now we discuss about some matrices problem. Matrices problem are too easy. We define in previous days, we define it in this way: m in R. Okay, that means element are belonging to R and n cross n matrices is obviously this one is isomorphic or isomorphic to Rn square. That means this one are a11 a this one Rn square means this one a11 a12 dot 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 in this way, and this one also this. Now we define this norm a norm equal to summation aij square whole to the power half. Okay, here ij, then this one equal to norm of a11 a12 dot 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 an, then 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 a sequence ak, then a sequence ak in mnr converges to a, converges to a if and only if the matrices, the matrices entries aij whole to the power k tends to aij as k tends to infinity for all ij. Okay, how we proceed this one? We proceed so simply: if every element, if every element aij whole to the power k tends to aij, then obviously for all k greater than equal to n higher n belongs to and for all ij, then obviously a or ak converges to ak, then ak obviously converges to a. Okay, in this way we write it. That means just matrices element to the power k when k greater than equal to n converges to aij, then ak with some matrices sequence which converts to a. Next we discuss further. If a key converging to a, then a k square converging to a square. How? That means if a k, this implies that the matrix entries aij to the power aij. Okay, if obviously this one implies if this one bij whole to the power k, then bij where bij equal to summation r equal to 1 to the air ar. Okay, then in this way for a k square tends to a square, if this one converts to this, then this one must converge to this. Bij to the power k, that means this whole to the power k, this whole to the power k, and means Bij to the power k summation r equal to 1 to 3 air whole to the power k converges to summation r equal to 1 to air. Okay. If this one hold, then we generalize this thing a k whole to the power r converges to e to the power r for r belongs. Next we further proceed. Now we further proceed. A key be a sequence of invertible matrices. A key be a sequence. A key be a sequence of invertible matrices. Be a sequence of invertible matrices. Be a sequence of invertible matrices in MNR. In MNR and converging to A. Okay, converging to A, then it is necessary that and converging to A, then is it necessary that A be invertible? Always not possible. We take for n equal to 1, ak equal to 1 by k converging to 0, but 1 by k be invertible on R, but 0 is not invertible. Next we're going to another problem. This problem is AK belongs to M in R, converse to A belongs to M in R. This implies that date of AK converts to date. How it can be possible? We write date of AK equal to AKDK minus BKCK converging to AD minus BC equal to date of. Okay. Determinant of a matrix is a polynomial in the entries, so we write convergent these things, then data of a k equal to this one. So today stop here.